Hi everyone, this is Ramakrishna. Welcome to my channel. In this video, I'm going to discuss CSIR NET December 2019 Real Analysis question number 21, Part B, 3 marks question. And the question is, let Z denote the set of integers and Z greater than or equal to 0 denote the set 0, 1, 2, 3 and so on. Consider the map F from Z greater than or equal to 0 cross Z to Z given by f of m comma z is equals to 2 power m into 2n plus 1. Then the map f is dash, and four options are: option number 1 onto means surjective but not 1 means injective. That means the given map is surjective mapping but it's not an injective map, means it is onto but not 1. And option number 2, map is 1 but not onto. Option number 3, both the given map is both 1 and onto. And option number 4, the map is neither 1 nor onto. So we have to choose one correct option from these 4. Okay, so here the question is about the mapping 1 and onto. So this is a basic fundamental question in real analysis. So if you like these videos, please share, subscribe my channel and give your comments on my videos. So let us recall the definitions of injective mapping and surjective mapping. So first we have injective map definition, that is 1 map. The map F from A to B is said to be 1. Here A and B are two non-empty sets, and F is a mapping from A to B is said to be 1 means injective map if f of A is equal to f of B, then A is equals to B, and that is true for all A comma B belongs to capital A. Or equivalent statement is whenever A and B is not equal, that means if A is not equal to B, then f of A is not equal to f of B. So this is also 1 mapping definition. Now we have surjective mapping definition, that is onto mapping definition. A map F from capital A to capital B, here capital A and capital B are two non-empty sets, is said to be onto mapping if for y belongs to capital B. That means in codomain we have to take every element y belongs to B. There exists at least one element x belongs to capital A, means there exists at least one element in domain A, that is x belongs to capital A, such that f of x is equals to y. That means every element in the codomain capital B has at least one pre-image in capital A, means in domain. Then we say that the mapping is surjective or onto mapping. And now coming to the problem, here given map is F from Z greater than or equal to 0 cross Z to Z is given by f of m comma n, because this is a Cartesian product, means domain contains set of all ordered pairs m comma n, where m belongs to Z greater than or equal to 0 and n belongs to Z. Your m value are 0, 1, 2, 3 and so on, and n value are integers, means either positive integers, negative integers or 0. Okay, because here Z greater than or equal to 0 means the given set is 0, 1, 2, 3 and so on. Okay, now here the mapping f from Z greater than or equal to 0 cross Z to Z is given by, and it is defined by f of m comma n is equal to 2 power m into 2n plus 1. So this is the given mapping. Now we have to verify that this mapping is 1 onto, whether it is 1 or onto. Okay, so first we will check injective property, that is 1 property, by using this first definition. So for that we have to take two elements order pairs. Suppose f of m1 comma n1 is equals to f of m2 comma n2. Okay, so by the definition we have this value is equals to 2 power m1 into 2n1 plus 1, and that is equal to 2 power m2 into 2n2 plus 1 by using definition of f. Okay, and here clearly observe that we have here this 2 power m1 means it is an even number, Similarly here also 2 power m2, this is also even number, and in the bracket term, that is 2n plus 1, this is an odd number. 2n 2 plus 1, this is also an odd number. So we have 2 power m1 is equal to 2 power m2, and similarly 2n1 plus 1 is equal to 2n2 plus 1. So on simplification we get m1 is equal to m2, and here n1 is equal to n2. Okay, so here we have the coordinate wise elements, that means m1 is equal to m2 and n2 is equal to n2. So from this we can write m1 comma n1 is equal to m2 comma n2. That means whenever two pair of elements images are equal, that means f of m1 comma n1 is equal to f of m2 comma n2. That implies we have m1 comma n1 is equal to m2 comma n2. That means there is a 1-1 mapping definition. If f of a is equal to f of b, then we have a is equal to b, and that is true for all a comma b belongs to capital A. So here the elements m1 comma n1 and m2 comma n2 are belonging to the set z greater than or equal to 0 cross z. This is a Cartesian product, means it containing set of all ordered pairs. So we have f is 1 1. Okay, so therefore f is 1 1. Now we have to verify that whether f is surjective or not. Okay, so now let us see onto. For onto we have here m value belongs to z greater than or equal to 0 and n value belongs to z, because f is a mapping from z greater than or equal to 0 cross z to z. Here domain is z greater than or equal to 0 cross z, and the codomain is integers z. So onto mapping means for every element in codomain, that means b, here b, in place of b we have integers z, we have to find preimage for every element. So for that, here we have two conditions. M belongs to z greater than or equal to 0. So we have two possibilities. If m is equal to 0, and similarly m is equals to 1, means it is greater than 0. So if m value is equals to 0, then by definition of f we have f of equal to 1, because here m value belongs to z greater than or equal to 0. So we have possibility m is equal to 0. In that case we have got set of all odd integers. If m is equals to 1, then f of 1 comma n, okay, sorry, this is f of 0 comma n, because definement is f of m comma n is equal to 2 power m into 2 power n plus 1. So by using the definition, if m is equal to 0, then we have f of 0 comma n is equal to 2 power 0 into 2n plus 1. 2 power 0 value is equal to 1, so we have 2n plus 1. So here 2n plus 1 represents all odd integers. Okay, if m is equal to 1, then we have f of 1 comma n is equal to 2 power 1 into 2n plus 1, which is equal to 2 into 2n plus 1. So it represents all even integers. Okay, it represents all even integers. But f of m comma n is equal to 0 is not possible for any m belongs to z greater than or equal to 0 and n belongs to z, because here we have f is a mapping from z greater than or equal to 0 to z. This is f. So in domain we have 0, 1, 2, 3 and so on, and here codomain we have negative integers, say, and so on, -2, -1, 0, 1, 2, and so on. So here we have even integers and odd integers, that is either negative even integers or positive even integers, or positive odd integers or negative odd integers. We have pre-images in z greater than or equal to 0, that is f of 0 comma n is equal to 2n plus 1, means all odd integers. Odd integers means it containing negative as well as positive odd integers. So we have for those elements we have an pre-image in z greater than or equal to 0, and similarly for all even integers also we have pre-image in z greater than or equal to 0. But for the particular element 0 we cannot find any pre-image in z greater than or equal to 0 cross z, because here domain is z greater than or equal to 0 cross z. So we cannot find any element in this set z greater than or equal to 0 cross z. So f of m comma n is equal to 0 is not possible for any m belongs to z greater than or equal to 0 and n belongs to z. So therefore f is not onto, means it is not a surjective mapping. That means our option number 2 is correct. Therefore option 2 is correct. So option number 2 is this is 1 but not onto. Okay, is it clear? I hope you like this video. If you like the video, please share, subscribe. Thanks for watching.